Hello, everyone. My name is Petr Špaček, to entertain you, and I work with CZNIC Labs on a project which is called Not Resolver, and that's new implementation of DNS Resolver. And today we will have a look how we benchmark the software and how we can make the DNS Resolver benchmarking more realistic. Let me see if I can operate clicker. Apparently I can't. Okay. That's too far. Great. Okay, motivation for benchmarking is very clear. If you are operating DNS Resolver for a significant number of clients, it costs real money. Obviously, optimization can translate to cost savings. That's easy one. Okay, this will be fun because the picture on the slide, graphics on the slides broke. Well, the most important thing to remember for this talk and for any DNS benchmarking you ever do is that the DNS query can be resolved in two different processes. In the first case, it is so-called DNS cache hit, and it practically means that the DNS resolver has all the data in its local cache and just pulls out the answer from the cache and sends it back to the client. That's super fast. The other option is that the DNS resolver doesn't have all the data and has to go to the internet, which is orders of magnitude slower. So keep in mind this difference, that it is super important. Now we can have a look at a very classical benchmarking method, which is implemented in a tool called resperf. And basically, the tool is reading a list of queries from a text file and sending queries to the DNS resolver under test at ever-increasing speed. QPS is acronym for queries per second. And the resperf starts with a low number of queries per second and is increasing the speed. And at the same time, monitoring responses from the DNS resolver. If the resolver is able to respond to almost all the queries, the resperf goes on and just increases the load until it reaches a point where the resolver is not able to respond to all of the queries. And at that point, the resperf will declare a victory again, over the DNS resolver and say, OK, the maximum number of queries per second this resolver can handle is X. So it will give you basically one number. That's it. The problem is that this is not really realistic, because as I've mentioned on the previous slide, the input for the resperf is a text file, and it is just going from top down through the text file, and it is completely ignoring any timing information which was in the original traffic. And again, there is a super important difference between cache miss and cache hit in the DNS resolver. And by ignoring the DNS TTLs, we completely mangle the cache hit rate, and thus we completely mangle the performance characteristics of that given DNS resolver. That's the most important problem. Second problem is that in practice, you never see ramp-up traffic, because if you restart your DNS resolver, clients don't care. They will just shoot the DNS queries at it, and that's it. So the ramp-up is not realistic at all. So we can summarize that and say that the resperf is typically over-focusing on the QPS, on the number of queries per second, but that's not really what you need, right? If you are operating serious network, you need the information how many clients the resolver can handle and not the number of queries per second. Otherwise, you have to somehow magically convert your number of queries per second to number of your clients in your population. Obviously, this conversion is not any general equation, right? Because every client is behaving a little bit differently. Little IoT device will have completely different DNS characteristics than mail server. So the answer, how many clients the resolver can handle, is not going to generalize for all the populations of clients and all the networks. Keep that in mind. For more realistic benchmarking, we at CZNIC Labs developed a tool called DNS Shotgun. It's based on awesome library by DNS.org. And most importantly for you, it's open source. OK. Principle of the tool is that it ingests your real traffic capture and then generates a load based on your own real traffic, and then, of course, it draws pretty charts. So the data preparation is basically taking your original PCAP, preferably taken from the real operating DNS resolver used by the real clients, and then it will pre-generate bulks of data for different number of simulated clients. So it will generate new PCAP with 100,000 clients in it, and then a second PCAP with 200,000 clients in it, and so on, as many clients as you want. Now we have the PCAPs with the simulated clients prepared, and we can start the actual test. So now we take the PCAP and reply to the resolver, and most importantly, we keep the timing through the test. So if the one particular client was sending one query and then had 1 second delay and sent different query because the TTL was 1 second, for example, the tool will keep the timing, so the cache hit rate will be realistic, or much closer to realistic, I should say. This is the basics. The basic process is very similar to RESPerf. We start with a number of clients, let's say 100,000 clients. Then we reply the traffic to the DNS resolver and monitor responses. That's the same. If the resolver is keeping up and answering almost all the queries, we can increase the number of clients, do the reply again, check that the resolver is keeping up, and so on and so on. At the point where the resolver is not able to answer all of the queries, we again declare the victory and say, OK, the resolver can handle this maximum number of clients, and that's it. OK, now we have a serious problem. Can we please get the presentation from PDF I sent you? This PowerPoint is totally broken, and it doesn't have the charts in it, so it's useless. Eventually, you will see a pretty chart. Every line on the chart describes a different client population. So we have like one measurement for 100,000 clients, second measurement for 200,000 clients, and so on and so on. And on the x-axis is time. We start with empty cache in time 0, and then as the time goes on during the test, the resolver is building its cache, and so its performance is actually improving over time, because again, the cache hit rate is the most important parameter. Let me see. Do we have some hope of getting the PDF? OK, working on it. The tool gives you an answer which is not generally valid for everyone in this room, or not even for every deployment of mine, because the performance very much depends on the particular configuration of the resolver, on the hardware you use, on the version of network drivers you actually use, version of Linux kernel, the client population, basically everything. So the most important takeaway is don't forget about the cache hit rate. And the second most important takeaway is always measure it yourself, because whatever I tell you will not probably apply to your situation. So really get the tool, get your data from your real traffic, and try to measure it yourself, because you will always get different results with different configurations and client populations. 4 minutes left. Well, does it include some pictures or not? Yeah. So this is the takeaway. Because we don't have the pictures yet, I will jump to conclusions, and then we will get back to pictures if we eventually get them. So the tool is open source. There is an URL. Oh, great. Thank you very much. Oh, yeah. We now have different version of the presentation, but again, without pictures. That's not really useful. Anyway, I will jump to the end, and we'll see. The tool is open source, so you can have a look yourself. The limitation right now is that it's doing only UDP. If you are interested in benchmarking TCP, TLS, or other fancy protocols, please talk to me. we are looking for sponsors to make it happen. And again, I repeat, please do not generalize the results you see in anyone else's slides or results. You really should measure performance yourself because it will be different for you. Trust me. If you feel that this talk is incomplete somehow, you can have a look in RIPE 79 archives. There is a video of longer version of this talk with actually pretty pictures and description of them. So look it up. And thank you for your attention. If there happen to be any questions, even though you didn't see anything, I'm happy to take them.
Hi, Robert Story, USC ISI. How do you generate additional clients when you need a load higher than the number of clients you have in your current PCAPs?
Yeah, that's for the long version of the talk. But the idea is that you can, okay, the basic idea is that you can capture the traffic for a longer time. So you keep recording your traffic for 1 day, and then you can compress the PCAP to like 10 minutes. So you basically take first 10 minutes, and that's n clients you have in your PCAP, and then you take second 10-minute window and run it in parallel with the first 10-minute window, and then you increase the number of clients as that. That's the basic principle. There is more to that. Okay, that's it. Thank you.